Hello students, in the last class we have started the topic determinants, and we have discussed how to expand determinant by using row expansion as well as column expansion. You know how to expand determinants of 2 by 2 as well as 3 by 3 order matrices. Now what we will discuss is solve some problems for that, and then we will go to the next topic. We have already solved 2 to 3 problems in the previous class by just using the expansion of determinants, how to find the value of determinant and how to find the missing number if the value of determinant is given. Now we will continue with solving problems in this topic and then move to the next topic. Okay, next problem is show that the determinant is independent of theta. What is independent of theta means? After expanding this determinant, there should not be any theta terms. Now it is easy. What we need to do first? The first step we should do is try to expand the determinant, and we already know how to expand determinant by using row as well as column expansions. Now by observation, here in the first column we have only theta terms, 1, it is a constant, so it is easy to expand this determinant by either first row or first column. Now we will expand this determinant by first row. Okay, first step is expand this determinant along row 1. Then what we will get? 1 into, then we need to leave this row as well as this column and row, and multiply the other two. Determinant of submatrix. That will be 1 into 1 plus sin theta into 1 plus cos theta. 1 plus cos theta minus of 1 into 1, multiply these two minus these two elements, that will be 1. Next element is minus of, first is positive, next one is negative, and then we will take positive sign. So next element is negative of 1 into, now what we need to do? Next we should leave this row, second element, whichever row and column that element is present, we should leave that and write the submatrix of other. So this will be, leave this row, first row and second column, and multiply the other two elements. That will be 1 into 1 plus cos theta, 1 plus cos theta, minus 1. Next, plus 1 into, now what we need to do? Leave the first row and third column. Then we will get 1 minus of 1 plus sin theta, 1 plus sin theta. So what is the expansion value of this determinant? This value is equal to 1 plus cos theta into 1 plus sin theta, that will be 1 plus sin theta plus cos theta plus cos theta plus sin theta cos theta plus sin theta cos theta minus of 1 minus cos theta minus cos theta minus 1 plus 1 plus, this will be 1 minus 1 minus sin theta. So what is the final answer? 1 plus cos theta plus sin theta cos theta is the expansion of first term, minus 1 minus cos theta, minus 1 minus cos theta, minus 1 plus 1 minus 1 minus sin theta. What is the value, students? Plus 1 minus 1 will get cancelled, plus 1 minus 1 minus 2, here sin theta cos theta will get cancelled, cos theta minus cos theta, sin theta minus sin theta. This will be sin theta cos theta minus 2. Correct? 1 plus sin theta plus cos theta plus sin theta cos theta minus 1 minus cos theta minus 1 plus 1 minus 1 minus sin theta. Yes. Final answer is sin theta cos theta minus 2. So what is sin theta cos theta? Sin theta cos theta is nothing but half of sin 2 theta. This is equal to half of sin 2 theta minus 2. Yes. Plus 1 minus this value. Correct. So final answer is half sin 2 theta minus 2. What is the value of maximum of this? This value's maximum will be when sin 2 theta is maximum, and maximum of sin 2 theta is 1. Therefore final answer will be half into 1 minus 2. That will be minus 3 by 2. So final answer is this one. Next question. Show that the determinant is independent of theta. Again what we need to do? Same as previous question. Show that the determinant is independent of theta. Now again we have to expand this determinant and show that it is independent of theta. When this determinant will be independent of theta? When there is no theta term after expansion. Now we will expand again this determinant. Expand along either row or column. We will take again row, expand along row 1. Then what is the determinant? Determinant value is equal to x into minus x square minus 1 minus of x square minus 1 minus of sin theta into minus x sin theta minus cos theta minus x sin theta minus cos theta plus cos theta into minus sin theta plus x cos theta minus sin theta plus x cos theta. Now what is the answer, students? Just multiply distribution property and write the answer. This will be, first term is minus x cube minus x plus x sin square theta plus sin theta cos theta plus sin theta cos theta. Again here minus sin theta cos theta minus sin theta cos theta. Again plus x cos square theta plus x cos square theta. That is it. Now what we can do is group the terms. Plus sin theta cos theta minus sin theta cos theta will get cancelled. Here this will be x into sin square theta plus cos square theta minus x cube minus x plus x into sin square theta plus cos square theta. And what is sin square theta plus cos square theta? This value is 1. So final answer becomes minus x cube minus x plus x sin square theta plus cos square theta is 1. So these two will get cancelled. Final answer is minus x cube. Here do we have any theta terms in this? No. So this expansion of determinant is minus x cube, which is independent of theta. That is the proof for this question. Easy questions. Next topic is finding area of triangle. Now by using determinants we can find area of triangle. You already know how to find area of triangle by using basic properties, basic formulas you are learning from class 6. What is the area of triangle? Half into base into height. We already discussed other types by using Heron's formula also. You know how to evaluate. Suppose if coordinates of vertices of a triangle are given, that is x1 y1, x2 y2 and x3 y3, then we can directly find the value of area of triangle by using determinant. That is one of the application of determinants. So how to find area of triangle? It is given by this formula. That is half into determinant of, write the first point x1 y1 and write 1 in the last column. Next x2 y2 1, x3 y3 1. So this expansion of determinant will give the area of triangle, and half of this value is the area of triangle. Now we have to remember, while expanding the determinant, it can take either negative value or 0 or positive value. Now suppose if this expansion is negative but area cannot be negative, so what we will do is take the modulus, absolute value of this area. That will be the actual area of the triangle. So first we will calculate half into determinant, and then we will take the absolute value. If this answer is negative, say -5, then we will consider 5 as the area of triangle. For example, similarly we can write, suppose if the area is 0, then what does that mean? When will area become 0? We have 3 points. Area becomes 0, area of triangle. That means that 3 points should actually be on a straight line. Only then there is no triangle formed and area will become 0. So what is the condition for 3 points to be in a straight line? That means it is collinear. So whenever 3 points are collinear, then we can say area of triangle is 0. That is another application. For finding if area of triangle is 0 means points are collinear, or sometimes in the question they may give 3 points are collinear. Then find some value or coordinate of some vertex, say x1 or y1, we should find some coordinate. Given 3 points are collinear. Questions can be asked in any way, but formula is same. Now area is always a positive quantity, so we will consider the absolute value of the determinant. Next, if 3 points are collinear, then the area of triangle is 0. We will consider one example and solve this. Find the area of triangle whose vertices are given by. We know 3 points, we should find the area of triangle. Now how to find the area? Area of triangle is given by half into determinant of, write the point x1 y1 1, x2 y2, that is -4 2 1. Next value is 5 1 1. Is that clear, students? How to write a determinant? For finding area of triangle, it is half into determinant of x1 y1 3 8 1, -4 2 x2 y2 1. Next x3 y3, that is 5 1 1. Now we have to expand this determinant. Now easiest way to expand this, we can take column 3, expand along column 3. And what is the sign? For column 3, this is plus, minus and plus. Now what is the value of determinant? Determinant value, we can write area also. Area equal to half into determinant of, that is 1 into, multiply the remaining 2, that will be -4 -10 -14, -4 -10. Next minus of, now we have to leave these two, then we will get, if we leave second row and third column, then we will get 3 minus 5 8s are 40, 3 minus 40 is -37. So minus of -37 will be +37. Next we have to leave the third row and third column, then we will get +1 into 3 minus 40, sorry, this we have to leave this now, 6 plus 24, sorry 32, 6 plus 20, 6 plus 32 is 38, correct now? Yes. For the last expansion, we will leave third row and third column. Remaining will be 6 plus 8 fours are 32, that is 38. Now what is the final answer? This is equal to 38 plus 37, 68, 75, 61. Actually answer is 61 by 2. Area is 61 by 2 square units. This is how we should calculate area of triangle. Sometimes in question they may give alpha comma 8 and remaining vertices, and these 3 points are collinear. Then find the value of alpha. That means again we will use the same formula. In place of whichever number is given, we will write as it is, and then value of determinant will be equated to 0. That's how we should find the answers. Right now. So this is another application of determinant. Final answer is 61 by 2 square units. Next is properties of determinants. So what are the properties of determinants? We have nearly 7 to 8 properties for determinants. We will discuss that one by one. First property is, if every element of a row or column of a square matrix is 0, then the value of determinant is 0. For example, what is the determinant of this? 0 into some number, that will be 0, minus of 0 into some number, that will also be 0, plus 0 into number, that will be 0. So what is the final answer? When any row or column of a determinant becomes 0, then when we expand from that row or column, actually we multiplying 0 with some number, so answer will always be 0. So that is the first property. That is, when any row or column of a determinant is 0, final answer expansion of determinant is also 0. Determinant is 0. Second property, the sign of a determinant of square matrix changes if any two row or column in the matrix is interchanged. We will discuss with one example. Okay, let A matrix equal to 1, 2, 3, 2, 3, 1, 3, 1, 2, and B matrix is, we will interchange first row and second row now. 2, 3, 1, 1, 2, 3, and 3, 1, 2. Now we will try to evaluate these two determinants. What is the value of this determinant? Determinant A is equal to determinant of 1, 2, 3, 2, 3, 1, and 3, 1, 2. Determinant B is equal to determinant of 2, 3, 1, 1, 2, 3, and 3, 1, 2. Now what is the expansion of this? This value is equal to 1 into 6 minus 1, that is 5, minus of 2 into 4 minus 3, that is 1, plus 3 into 2 minus 9, that is minus 7. So what is the final answer, students? 5 minus 2 minus 21. So final answer is 5 minus 2 is 3, 3 minus 21 is minus 18. So determinant A is equal to minus 18. What about the determinant B? This is equal to 2 into 4 minus 3, that is 1, minus 3 into 2 minus 9. 2 minus 9 is minus 7, plus 1 into 1 minus 6, that is minus 5. So what is final answer? This is 2 minus plus 21 minus 5. So final answer is 18. So when we observe these two determinants, it is magnitude is same but sign is opposite. So what does that mean? Determinant A is negative of determinant B. That means when we interchange any two rows or columns of a determinant, its value will get negated. That is the second property. Now it is given us for any element, instead of taking 1, 2, 3, some example and seeing for any element, how will this property be? We will just erase this and see. Okay. Let A matrix is given by this: A1, B1, C1, A2, B2, C2, and A3, B3, C3. Now if we interchange these two, R2 and R3, for example, then let's take B matrix as interchanging row 3 and row 2 of A matrix. Then what is the expansion? Determinant A, that is equal to A1 into this value. We already know how to expand. So final answer is this one. And what about expansion of determinant B? Again we will follow the same procedure, expansion along row 1. So final answer comes out to be this value. And when we observe first term, here this is minus of A1 B2 A1 C2 B3, here plus A1 B3 C2. So actually both are negative sign. Similarly all terms will be negative of that. So final answer becomes negative of determinant A. This is the proof for second property. Next property is, if any two rows or column of a square matrix is identical, then the value of determinant is 0. Now we can add one more statement here. Any two rows or column is identical or proportional. For both these cases, answer will be same. When any two rows or columns of a determinant of a matrix is identical, then the value of determinant becomes 0. For example, what does this mean? Determinant of 1, 1, 1, 1, 1, 1, 2, 3, 4. Let's take this as some determinant of A matrix is equal to. Now what is the expansion of this? If any two rows or column becomes identical, that means here R1 and R2 are identical. When we expansion we can do it by row 3. Then what will be the answer? Expand along row 3. Expand along row 3. Then we will get 2 into 1 minus 1, that is 0. 2 into 1 minus 1, 0. Minus 3 into 1 minus 1, 0. Plus 4 into 1 minus 1, again 0. So what is the answer? 0. That means when any two rows or columns of a determinant becomes identical, its value is 0. What about proportionality? Say take another matrix. Determinant B is equal to 1, 1, 1, 2, 2, 2, 2, 3, 4. Now this is proportionality, and we already know the property. We can take the scalar multiple of any row or column outside the determinant, its value will not change. Determinant of, for some element here, if any row or column is multiplied by scalar k, then its determinant is k into that determinant value of remaining. So this is nothing but 2 into, we can take 2 outside from second row, then we will get 1, 1, 1, 1, 1, 1, 2, 3, 4. Again these two determinants are same, determinant A and this determinant is same. So we already know the value of this, it is 0. So final answer is 0. So that is what this property means. Any two rows or column of a determinant is identical or proportional implies value of determinant is 0. Again let A matrix is this one. What is the expansion of determinant? We already know how to expand determinant. Final answer comes out to be this. And these two elements are same. Similarly, all the terms get cancelled out. So what is the final answer? Expansion of this determinant is 0. Next property. If all elements of row or column of a square matrix is multiplied by a number k, then the value of determinant is obtained as k times the determinant value of the given matrix. This is what we have discussed in the previous property also while expanding the second determinant. So when each row or column of a matrix is multiplied by a number k, the value of determinant will be k times the value of given matrix. So proof is from the previous slide itself. How do we expand the first determinant and second determinant? From that you can understand this example. Let A be equal to this matrix. Then if you multiply each of the elements of first column, here we are multiplying each element of the first column with some number k, then that be B matrix equal to this. Then actually determinant B is k times determinant A. That is what we need to prove. We can take k outside this and find the determinant of remaining matrix. That is what this property means. We will expand and say determinant A is, let's take this value. Now again if we expand, we can expand by column 1. Here also we can expand by column 1. That will be easier to understand. So we will get A1 into remaining terms minus of A2 into plus A3 into multiply the other submatrix, determinant of submatrix. Here again we will have KA1 into same elements minus KA2 plus KA3. That means if you take K outside, the value of the remaining terms will be same. So this determinant B is nothing but K times determinant A. Now we are expanding and checking. So determinant B expansion is KA1 into this minus B1 into plus C1 into. So final answer is, again we are multiplying by each term with K. We can take K common outside. This value is nothing but determinant of A. So this is the proof for the property. Next property is, if each element of a row or column of a square matrix is the sum of two numbers, then the value of determinant can be written as sum of two determinants. We will discuss this property with an example. Suppose we want to find the value of determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, what is the value of this determinant? When we expand this determinant, its value becomes 1 into 5 9s are 45 minus 8 6 are 48, that will be minus 3. 45 minus 48, next one minus 2 into 4 9s are 36 minus 42, that is minus 6, plus 3 into plus 3 into 4 8s are 32 minus 35, that is minus 3. What is the final answer? This will be minus 9 minus 3 minus 12 plus 12 becomes 0. So final expansion of this determinant is actually 0. Now we will try to split this determinant into two parts. We can write this elements as 4, 5, 6 as in terms of 1, 2, 3. Then we can write this as 1 plus 3, 2 plus 3 and 3 plus 3. So we can write this determinant by splitting the second row in terms of, we can write this determinant as 1, 2, 3. We will write 1, 2, 3 again, 1, 2, 3, 7, 8, 9 plus determinant of 1, 2, 3, remaining term is 3, 3, 3. 3, 3, 3 and 7, 8, 9. This is what this property means. Now next, we already know what is the value of this determinant. By previous property we have discussed, if any two rows or columns of a determinant is identical, its value becomes 0. So this value of determinant is actually 0. What about this determinant? Again we can use this, expand this determinant by, we can again split this 7, 8, 9 in terms of We can write this in terms of again 1, 2, 3. Now this will be 1 plus 6, 2 plus 6, 3 plus 6. Now this expansion becomes determinant of 1, 2, 3, 1, 2, 3, 3, 3, 3, 1, 2, 3, 1, 2, 3 plus determinant of 1, 2, 3, 1, 2, 3, 3, 3, 3 and 6, 6, 6, 6, 6, 6. Now what is the expansion of this determinant? Determinant first expansion becomes 0. Why is that? Because R1 and R3 are identical. So this determinant value is 0. What about the second determinant? It is also 0. Why is that? Because R2 and R3, row 2 and row 3 are actually proportional. We can take 3 outside from row 2 and 6 outside from row 3. That means we will have 1, 1, 1, 1, 1, 1. So this expansion determinant is also 0. So what is the final answer, students? It is 0, which is same as the expansion of this determinant. That is what this property means. Let A matrix equal to A1 plus X1, A2 plus X2, A3 plus X3, B1 C1, B2 C2 and B3 C3. Then we can write this determinant as sum of two determinants, that is A1, A2, A3, write the remaining as it is, plus X1, X2, X3, write the remaining columns as it is. B matrix is this value A1, A2, A3 remaining as it is. C matrix is X1, X2, X3 and write the remaining terms as it is. Now we will try to evaluate this determinants. Determinant A is equal to, just you already know how to evaluate, find all the determinant values and try to see if determinant B plus determinant C is determinant A or not. So determinant A value comes out to be this one. Determinant A is nothing but determinant B plus determinant of C. That is the proof for this property. When any row or column of a determinant can be expressed as a sum of two terms, then the value of determinant can be expressed as sum of two determinants. Next property is determinant of a triangular matrix is product of diagonal elements. We can also take determinant of triangular matrix also diagonal matrix. Any determinant of diagonal matrix will be product of its diagonal elements. We can also add triangular or diagonal matrix. Anyway, triangular matrix is a special case of diagonal matrix. So here this is a triangular matrix. When we try to expand this along column 1, then we will get P into QR minus 0. Next two terms will be 0. So what is the final answer? PQR, which is nothing but the multiplication of diagonal elements. It will be same for lower triangular matrix also, upper triangular matrix also. So this is the property 6. Next property is, if A and B are two matrices of same order, then determinant AB is equal to determinant A into determinant B. Instead of multiplying the two matrices and then taking determinant, we can find the determinant of two matrices separately and then multiply. That is the 7th property. Again, this is very important property. We will use this in objective questions as well as they may ask to prove in subjective questions. Show that this property holds for some matrix they may give. So these types of questions can be expected in your board exams. Also we can remember, we already know how to find transpose of a matrix, which is nothing but interchanging rows and columns of a matrix. Then determinant A will be equal to determinant of A transpose. Both will be actually same. We can consider that as the next property, property 8. That is also a very important property. We will solve some questions using properties. First question is, we have to show that this expansion is 0. Either we can multiply directly or we can expand directly or use the properties of determinants and try to evaluate the determinant. Based on the question, we have to analyze which method will be easier to solve. For different questions, what type of transformations, elementary transformations need to be applied. Now here determinant value is equal to 0 is given. We have to show that this determinant is 0. That means first, while observing, we already know what is omega. Omega is cube root of unity, and we already know the property. We already know omega cube is 1, omega is cube root of unity, and what is the other property? Sum of cube roots of unity, that is 1 omega and omega square equal to 0. Now we will try to use these two properties of omega and try to evaluate the determinant using determinant properties. Now we can write the determinant as determinant of, add all the rows. If we add R1 plus R2 plus R3, then we will get 1 plus omega square. For the second, it is also same, 1 plus omega square. Third row, third column is also same, omega square plus 1 plus omega. We can write the remaining as it is. Remaining rows are written as it is. Omega square 1 omega. Now this value becomes 0. 1 plus omega square is 0. This value is 0. Again 0. Again 0. So what is the expansion? Expansion is 0. Because we already know if value each element of a row or column is 0, then the value of determinant is 0. So final answer is 0. This is one way to prove this property. Sorry, should prove for this question. Or we can also add column wise. Here what we did? We have actually added R1 implies R1 is transformed to R1 plus R2 plus R3. This is the transformation we have applied. Add all the rows. We will discuss the solution. So now instead of adding row wise, we can also add column wise. So then what we will get? Again 1 plus omega square, omega plus omega square plus 1, omega square plus 1 plus omega. Now first column becomes 0. When we add all the columns, then first column becomes 0. What is this? It is 0. 0, 0, 0, and write the remaining columns as it is. Final answer is 0. Depending on the questions, we have to analyze which transformation we need to apply so that this expansion will become simplified. It is not necessary that we can only have one type of expansion of transformation that need to be applied. Depending on the question, we have to see. Next one, show that this determinant value is 0. Now again by observation, if we expand this directly, each term in the determinant has two elements, two terms. Then when we multiply, it will be very big term. So what we need to do is try to simplify using properties of determinants. So what is the first row? A minus B, B minus C, C minus A. Similarly, other rows we will try to analyze. Here we have minus B, minus C, plus A, minus A. That means when we add all the rows, actually this becomes 0. So our purpose of expansion by using properties is to make maximum number of zeros or try to simplify the given determinant so its expansion is easier. Now this determinant value is 0. First element becomes, when we add all the rows, it becomes, determinant value becomes minus A plus A will get cancelled, minus B plus C, minus C plus C, minus B plus B. So first term becomes 0. Second one, again B minus B, minus C plus C, minus A plus A. When we add all this, it is 0. Third one, again C minus C, B minus B, A minus A, it becomes 0. And write the remaining as it is. That will be B minus C, C minus A, and A minus B. Next one, C minus A minus B, A minus B, and B minus C. value is 0. Okay, next, this is actually 0. That is the proof for this. Again, instead of adding row wise, we can also add the columns. Minus b plus b, minus c plus c, minus a plus a, it becomes 0. So instead of when we add column wise, first column will become 0 similarly. So here matrix is this one, value of determinant while expanding. If we add all the columns, first column will become 0. So what is the final answer? It is 0. Next question. Show that this expansion of this determinant is a cube plus b cube plus c cube minus 3abc. Now we will try to understand this question. We can do in different ways. First I will tell you one method to solve this question. Here we have two terms in the first two rows and one element in the third row. Then we can try to minimize these two elements into a single element, then it will be easier to expand, or we can try to make more number of zeros. Or what is this element here? This right hand side is actually a cube plus b cube plus c cube minus of 3abc. And what is this formula? It is a standard formula. This is equal to, actually it is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. When we expand this, when we multiply these two terms, we will get this. This is a formula for three terms. Basic algebraic formula. Now while expansion, if we try to get this term, then its determinant value will be this, equal to this. Then what we can do is try to observe, can we make first term or second term from the determinant? Here b plus c is there, a is there in the second, third row, c plus a, b, a plus b, c. Then when we add r1 and r3, then we will get a plus b plus c in the first row. So what we will do is, determinant equal to, add r1 plus r3, a plus b plus c, a plus b plus c, a plus b plus c. Write the other two rows as it is, a plus b, b plus c and c plus a, b and c. Now a plus b plus c is common, we can take it outside, a plus b plus c into, write the remaining, 1 a plus b, a, 1 b plus c, b, 1 c plus a, c. Next what we can do is, from third and second row, a plus b minus a will become b, b plus c minus b, c plus c minus, c plus a minus c will become a. So we can subtract these two rows, then we will get a single element, it will be easier to expand. That is one way. Or we can also subtract column wise. This is equal to, again a plus b plus c into, we can subtract column wise or row wise. Try to make maximum number of zeros. For now I will do row subtraction. Then what we will do is, write this as it is, 1 1 1, a plus b minus a, that will be b, b plus c minus b, c, and the third row is a. Next is a, b, c. Now we will expand this. This is equal to a plus b plus c into, a plus b plus c into, the expansion of this is 1 into c square minus ab, c square minus ab. Next one, minus 1 into bc minus a square, that means plus a square minus bc. Next, plus 1 into b square minus ac plus b square minus ac. Now what is this? A plus b plus c into a square, c square plus a square plus b square minus ab minus bc minus ac. This is nothing but a cube plus b cube plus c cube minus 3abc. A cube plus b cube plus c cube minus 3abc. This is one way to solve this determinant. Okay, I think this is clear now how to use properties of determinants to evaluate determinant value. Now we will discuss the solution given here. Solution is, left hand side is this one. Here what they have applied is, first subtract these two rows. Then we will get a single element in second row. R2 is transformed to R2 minus R3. So then we will get BCA in the second row and the remaining as it is. Next what we are doing is, R1 is transformed to R1 minus R2. Now if you subtract R1 and R2, plus B minus B, plus C minus C, plus A minus A, those two will get cancelled, then we will get a single element in all the rows. So value of determinant is nothing but CAB, BCA and ABC. Now we will expand this. Now it is easier to expand as there is only one term in this expansion. C into C square minus AB minus A into, leave these two rows and column, and then BC minus A square plus B into, now leave this row and column, B square minus AC. So final expansion becomes A cube plus B cube plus C cube minus 3ABC. So this is another way to solve. So from this what we have understood, it is not necessary that we have to follow same transformation or use a single type to solve, get the value of determinant. We already know how to use elementary transformation, we have discussed in matrices. We can use those types of transformation, try to simplify the determinant value. That is what is our purpose. Next is singular matrix. What is a singular matrix? When determinant value becomes 0, then that matrix is called a singular matrix. A square matrix A is said to be singular if determinant A equal to 0. For example, what is the expansion of this determinant? 2 into 10, 20 minus 4 into 5 is again 20. 20 matrix. Next is non-singular matrix. What is a non-singular matrix? When determinant is not 0. As simple as that. When determinant becomes 0, it is a singular matrix. When determinant is non-zero, it is a non-singular matrix. Determinant A is not equal to 0. For example, we will take another matrix. 3, 6 are 18 minus 8, that is 10, which is not 0. So this matrix is a non-singular matrix. Next, what is a minor of element? We will find the minor by using determinant of submatrix. Minor is nothing but determinant of submatrix. What does that mean? We have to leave the row and column in the matrix and write the submatrix determinant. For example, we will take one example instead of using this. Determinant of 2, 3, 1, 3, 4, 5 minus 2, 1, 3. Now it is given like this. Normally how we will write minor? It is denoted by Mij. What is I? Row number, and J is column number. When we write M11, that means minor of element, first element, that is 2. M21, that means minor of second row and first column, that is 3. Minor of 3, that means M21, minor M21. For finding the value M11 equal to, for example, M11, then what we need to do? Just like how we expand, leave that row and column and find the determinant of other. That will be 4 into 3 is 12 minus 5 is 7. So first value is 7. This so we should calculate. Now we will do another example. Now for the next example, say M23, we want to find the M23. What is second row and third column? This element. So we will subtract leave these two rows and column, and then we will see the determinant of other elements. That will be 2 into 1 is 2 plus 6, that will be 8. Clear now? So this is how we should calculate minor of element. While expanding determinant, we will consider the sign of each element. For finding minor, we don't need to consider the sign. Just evaluate the determinant of submatrix. That is minor. And it is generally denoted by M11, M23, that is Mij. Now the minor of A2, for example, that means leave this element row and column, leave this row and column, and find the determinant of other elements. That will be B1, C3, B3, C1. That is the answer. Clear now? For another example, minor of B3. B3 is here. What is the minor? Leave the second column and third row and find the other value. That is A1, C2 minus A2, C1. So that is how we should find the minor. Next is cofactor. Cofactor is nothing but the signed minor. What do you mean by that? Cofactor is nothing but the signed minor. And how to choose the sign? It is based on how do we expand the determinants, the same property. When we add the row and column number, if it is an even number, we will take positive sign. If it is an odd number, we will take negative sign. And write the minor of that element. So cofactor of element is in the ith row and the jth column of a 3 by 3 matrix. It is given by, defined as the product of minus 1 power I plus j and the minor of aij. Cofactor of element, it is generally denoted by capital Aij. Minor is capital Mij and cofactor is capital Aij. We also have another notation for cofactor, that is Aij, or it can also be written as capital Cij, which is cofactor of ijth element, or sometimes it is also represented by capital F. Capital F, Ij. All the three notations are same. Cofactor is Aij or Cij or Fij. Now what is the cofactor of element Aij? It is nothing but the signed minor, that means minus 1 power I plus j into minor of the element. Cofactor of element is minus 1 power I plus j into minor of the element. For example, take a square matrix like this. Cofactor of element is minus 1 power I plus j into minor of that element. For example, cofactor of A2. A2 is here. Then what we need to do? Which is the row and column number? Row is second row and column is first column. So final answer is minus 1 power 2 plus 1. Add the row and column number into minor of this. So we will leave the row and column and find the value of minor. This is minus 1 power 3, which is negative sign, and leave this row and column and write the multiplication of other two. That is B1 C3 minus C1 B3. So final answer is this one. Clear now? This is how we should find the cofactor. Now cofactor of element is this one. Cofactor of what is cofactor of B3? B3 is here. And this is in third row and second column. That means minus 1 power 3 plus 2, minus 1 power 3 plus 2 into leave that row and column, multiply the other two. Value of determinant of submatrix. That is minor of B3. Minus 1 power 5 into, leave this row and column, remaining will be A1 C2 minus A2 C1. So final answer is this one. Okay, now we will discuss a question. Find the minor and cofactor of all the elements in the given determinant. Okay, what is minor? Minor of first element, that is M11, that is equal to 1 is there. Leave 1 this row and column, first row and first column. Leave first row and first column, and determinant of submatrix, that is only one element is there. That means minor of 11, minor 11 M11 equal to determinant of remaining element, that will be Determinant of 1 by 1 matrix is same number. So here we will have determinant of 3 is 3 alone. So this is how we should find. What is M12? M12 will be first row, second column, then leave this row and column, remaining will be 4. Similarly, M21, can you answer students directly? M21 will be opposite to 4, that is minus 2. M22, that will be 1. M23, these elements does not exist. So this is the minor value. Now what is cofactor? Cofactor is given by A11, A12, A21 and A22. Now A11 will be minus 1 power 1 plus 1 into M11 into M11, that is minus 1 power 2 is plus 1 into 3, that is 3. Final answer is 3. Now A12 will be minus 1 power 1 plus 2 into M12. Minus 1 power 3 is minus 1. So final answer is minus of 4. Now can you answer for A21? A21 will be minus of, because 2 plus 1 is 3, odd number means minus. Minus of minus 2 is 2. Next 2 plus 2 is 4, even number, minus 1 power 4 is 1. Answer is 1. This is the cofactor values of all the elements. Minor and cofactor. This is how we should calculate this. Minus and cofactors of the elements and the determinant is given by this. Next is find the cofactor of element A23. A23 is here second row and third column. Second row and third column. What is cofactor? Capital A23. That is given by minus 1 power 2 plus 3 into M23, which is given by minus 1 power 5 is minus 1 into minor 23 is 5 into 2, 10 minus 3. 10 minus 3 is 7. So answer is minus 7. This is how we should calculate minus and cofactors of matrix. Clear now students? Easy questions. With this we have completed this topic now. Next we will discuss adjoint of a matrix and inverse of the matrix in the next class. And keep learning and keep growing with Tapasya students. Success is yours line by line. Endigu namma Tapasya.